Welcome to this module on green hospitals. I am Kushal Matai, a research scholar in Department of Architecture, School of Planning and Architecture, New Delhi. In this module, we shall discuss green hospitals. First of all, climate change. Climate change is a reality brought into a spotlight with rising temperatures which result in dying of crops, melting glaciers, decreasing precipitation levels at global level. The atmospheric carbon dioxide levels have never been like they are right now. As you can see in the slide, that the carbon dioxide levels which were in the past millennia has gone very up. The modern healthcare sector not just contributes towards this grave phenomena, but it itself being affected by it. Healthcare sector, through its consumption of a large number of resources, construction and operation of complex establishments, employment of sophisticated energy intensive technologies, and generation of an array of waste, has itself become a public health concern. In India, the commercial sector, which includes the healthcare sector, consumes 7.58% of the total electricity, which makes green hospitals inevitable. WHO defines green hospitals as a hospital which responds to local climate conditions and optimized energy use. A green and healthy hospital is the one that promotes public health by continuously reducing its environmental impact and ultimately eliminating its contribution to the burden of disease. A green and healthy hospital recognizes the connection between human health and the environment through its governance, strategies, and operations. It connects local needs with environmental action and practices primary prevention by actively engaging in efforts to foster environmental health, health equity, and a green economy. Green building ratings add credibility to the hospitals by measuring various parameters such as waste, water, energy against a set of benchmarks. A standard performance scale is generated which helps in determining the robustness of the claims of sustainability. Sustainability has three pillars, which are environment, economy, and society. Any green project must strive to address all three to maintain a holistic balance. A green hospital is one that aims to reduce the use of raw material by efficient design and execution, reduced energy consumption by utilizing natural resources such as daylight and energy efficient equipment, improves process efficiency to be user friendly, reduces waste generation and manages waste well, utilizes renewable and recoverable resources, reduced incidents of infection and ensures better occupant comfort. India as a country is lagging behind in making green hospitals. One of the major barriers is the lack of awareness in the owners, developers, and the facility managers about the benefits of green buildings. The hospital buildings use a lot of resources and generate huge amount of biomedical waste, which makes integrating sustainability more challenging. This becomes a deterrent for most project teams. The health and safety regulations for a hospital are quite stringent and cannot be compromised with. This pushes sustainability even further down the ladder. There is a lack of adequate operational structure to take decisions, identify goals, and ensure the execution. The issues related to green design are still relatively new and require additional skills which are not widely available. The first step of any project is selecting a site and initiating conceptual design. The project must ensure that there is a management system in place to manage the hospital, develop plans, document progress, and ensure implementation. A thorough site analysis must be conducted to analyze the surroundings, connectivity of the site, infrastructure availability around the site, Environmental impact assessment of the site helps in determining the ecological conditions of the site, vulnerability of the ecosystem, availability of the resources, etc. The project team must strive to preserve the available natural resources on the site such as fertile topsoil, trees, natural drainage and natural features. The construction activity contributes to the noise pollution, air pollution and soil contamination and must be curbed at the time through planning and measures. This is an example of site selection process which highlights the major steps of the process. It includes identifying existing infrastructure, avoiding obstruction of natural drainage lines, identifying access to the other facilities and the relation of the project with its surroundings. The building's form, orientation and massing affect its climatic response. These basic principles must be applied to make a hospital green. The example being shown here is for hot and dry climate. Similar strategies should be explored and applied as per the location of the project. Optimizing buffer spaces, utilizing principles of courtyard design and cross ventilation as per the location of the project helps in enhancing the climatic response of the project. A hospital requires open spaces where visitors can wait, semi-open spaces to absorb the sudden increase in footfall. Hard paving and dark surfaces increases the temperature of the areas and creates uncomfortable environment. Use of light colored and reflective surfaces helps in reflecting the excessive sunlight back to the sky. This could be further enhanced by shading the open areas which then act as areas of respite. One of the most critical aspects and success factors of a hospital would be its patient safety and recovery rate. The most direct way of providing patient safety would be reducing infections and providing a healthy environment for patients. Therefore, it is critical that the protocols are set for operation of HVAC and lighting which ensure that the optimum level of occupant comfort is achieved by the hospitals. The design of the built environment is found to impact patient safety. Indoor environment quality has been considered as an important factor not only for patient recovery but also for nurses and other staff satisfaction. Availability of daylight and uninterrupted views of nature in hospitals are found to decrease stress levels in the workplace for nurses. The footfall in a hospital is quite high and has a diverse range as well. The movement of patients, doctors, staff, housekeeping, etc. must be planned to ensure safety and ease. Parking for emergency, for patients, for visitors and for staff must also ensure smooth movement. A building management system which can detect contamination, monitor the levels of air quality and can raise warnings is specifically helpful in a hospital. Occupant comfort include visual, thermal and acoustic comfort. The first step of ensuring occupant comfort is controlling the amount of heat entering a hospital. India has high quantities of solar insolation which should be controlled by minimizing the window to wall ratio and skylight to roof ratio. Solar heat gain coefficient of a glass also affects the amount of heat entering the interiors. The ample amount of daylight available in our country must be harnessed for a healthier indoor environment. As a hospital is run 24 days, 7 hours, the design of artificial lighting also becomes an important factor in ensuring comfortable interiors for the users. Too harsh or too dull lighting can affect the biofeedback of users, negatively. Air circulation, air changes and temperature ranges affect the indoor environment quality, so these must be closely monitored. Additionally, adequate insulation must be provided to decrease the intensity of outdoor and equipment noise. Finally, low VOC paints and adhesives help in decreasing the amount of emissions inside the environment and enables indoor environment comfort. The Energy Conservation Building Code (ECBC) lays down detailed requirements and threshold to ensure good daylighting inside the hospital. It also establishes thresholds for artificial design by giving interior lighting power allowance thresholds for different spaces in a hospital. There are two ways of determining interior lighting power allowance. First is space function method, second building area method. Shown here are the required lighting power density LPD for the different space types in a hospital in order to achieve various energy efficiency performance levels. Hospital interior lighting power density allowance by the building area method of ECBC, ECBC plus and Super ECBC are 9.7, 7.8 and 4.9 respectively. The project can choose to be more efficient by selecting the Super ECBC threshold. The following elements are fundamental to indoor air quality: contamination source control, proper ventilation, humidity management and adequate filtration. Various shading strategies help in ensuring diffuse daylight in the interiors and stop the direct sunlight from heating up the interiors. These strategies differ in various climatic zones and regions. Studies have shown that the patients staying in hospital rooms with windows facing trees have higher well-being and recovery rate than a group of patients staying in rooms with windows facing walls. Using plantation to shade the areas enhances the effect of shading strategies. Additionally, the plantation also helps in groundwater recharge, reducing urban heat island effect and enhancing the microclimate of the area. Most of the hospitals in India have no systems for effective and safe disposal of their waste, which finds its way to the open bins on the roadside or the low-lying areas or is discharged into the water bodies. Improper disposal of such waste, especially as open dumps, attracts a host of disease vector, release unpleasant odors and may also lead to transmission of diseases. A hospital must comply with the biomedical waste management rules to ensure appropriate collection and disposal of the various kinds of biomedical waste generated in a hospital. Adequate waste management system must be designed to aid in effective collection and disposal of harmful toxic chemicals and biomedical waste. A framework must be established to ensure that only environmentally friendly material is used in the hospital. The materials which are used in interiors of a hospital can affect the health of the users. Therefore, it must be ensured that low emitting materials such as paints with low volatile organic compounds VOC, lead free paints are used. All chemicals or gases being used in the hospitals must be stored as advised by the manufacturer to avoid accidents. Health facilities can cut waste and emissions through composting, recycling, better purchasing, using reusable rather than disposable products and buying recycled products and minimizing waste transport. Huge quantities of materials is used to construct the hospitals. With climate change and resource depletions, the material supply is also being affected. The project must aim at closing the loop in materials to reduce wastage, to use rapidly renewable materials and recycled materials more. Healthcare facilities utilize vast quantities of water. Climate change, with its accompanying impacts of drought, glacier melt, and aquifer depletion, will exacerbate water scarcity. A plan must be developed which focuses on the ongoing water usage of the facility. Measurement of the water demand, steps to reduce the water requirement, and verification of the water usage. This helps in making water management dynamic and evolving. Water conservation, water recycling, and rainwater harvesting strategy must be an integral part of the building design and operations. This will ensure that water shortage does not impact projects largely and the treated waste water and rainwater is utilized. Finally, there should be an ongoing educational program to inculcate the culture of efficient water usage, conservation in the stakeholders. As the groundwater resources deplete, rainwater has become a precious source of fresh water. It could be collected wherever it falls and used after minimum amount of treatment required. The project team should calculate the rainwater harming potential of a project based on the available area and the rainfall of the region. The catchment area, the slopes and the surface finish affect the runoff of the surface water which could be collected. The project should determine feasibility of collecting rainwater from the roof or on the surface area. Finally, appropriate green infrastructure should be developed to enable collection, filtration and percolation of the rainwater. Treated wastewater is a resource which has been wasted quite often. By providing sewage treatment plant, a hospital can access to extra water within its premises, which decreases the dependency on groundwater. Additionally, it also helps in maintaining the quality of the water from water sources. There are various types of sewage treatment systems available such as packaged units, decentralized wastewater treatment systems, DWATs, improved septic tanks. Most of the energy utilized in the hospital is procured from the outside, either in the form of different fuels or electricity, and thus constitute a significant proportion of a hospital's operational cost. HVAC systems are the energy guzzlers in a hospital but provide thermal comfort, prevent infection as well as ensure good indoor air quality. Lighting requirement of a hospital varies from providing average lighting in waiting areas to special lighting in the operation theatres. It is also affected by the time of the day and the occupancy. Processes such as catering, laundry and instrument sterilization require steam. Diesel guzzling and smoke belching standby power generation sets are commonly employed for energy generation in hospitals across India because of chronic power shortages. Effective energy management of a hospital can be done by following the mentioned steps. First and foremost is the compliance with the Energy Conservation Building Code (ECBC). This code enlists steps to make a building energy efficient by addressing HVAC systems, lighting requirements, equipment selection, etc. The next step is to optimize the building envelope to ensure that the adverse impacts of the climate such as too much heat or too much cold are not least impacting the indoor comfort of the hospital. This will also reduce the pressure on the HVAC system. India has good amount of daylighting available around the year, which should be harnessed to reduce the need for artificial lighting. Then the total energy demand of the project must be calculated to get clarity about the energy needed to run the hospital. The final step is integration of renewable energy into the project to reduce the dependency on fossil fuels. As per ECBC 2017, minimum 2% and 4% of total electricity load is to be generated by renewable energy zone for ECBC plus and super ECBC buildings respectively. A hospital project must install energy systems which are compliant with the statutory norms. An energy conservation plan must be in place. Smaller measures such as switching to compact fluorescent and light emitting diode, LED bulbs, turning thermostats down by just a few degrees in the winter or up a little in a summer, purchasing energy efficient products, reducing standby energy use and retrofitting buildings to cut energy waste can have a major impact. Measurement and accountability helps in ensuring optimum running of systems and controlled energy usage. Harmful refrigerants affecting the ozone layer are being phased out according to Montreal Protocol. A hospital must have a phase out plan considering the huge quantities of refrigerants and firefighting equipment required by the project. Lastly, regular energy audits ensure that building runs efficiently and any issues or concerns are identified as they arise. Building operations are crucial for implementation, maintenance and management of the integrated sustainability features. Therefore, there must be a good building management plan in place which will act as a framework for the team. Repair and replacement of equipment, material and instruments is an ongoing process in the lifetime of any building. The housekeeping and building operations team must have a purchasing policy to encourage purchase of environment friendly materials, recycled materials and low VOC materials. Huge quantities of waste is generated when any equipment is disposed of considering the quantity of medical equipment and instrument in a hospital, the end of life management for the purchased and the inherited equipment must be a part of operation of a hospital. The housekeeping and cleaning policies should be in alignment with the green hospital standards. As the staff in a hospital keeps changing, there must be an induction program to bring them onto par with the practices and protocols of maintaining a sustainable hospital. Diets based on saturated fats, refined carbohydrates and processed foods are increasing the burden of non-communicable diseases which requires long-term therapies. This increases the healthcare cost and also the healthcare sector's environmental footprint. Health by providing fresher, good tasting, nutritious food choices for patients and staff and also by supporting food production that is local and protective of the environment and health. Therefore, the hospitals should encourage sustainable food purchasing policies and procedures. Furthermore, a lot of chemicals are used for cleaning the food preparation and serving areas. Pest management is also integral in maintaining a clinically safe environment. These chemicals are usually hazardous and affect the surroundings with their toxic fumes. They further pollute the water as they are flushed down in the toilets, kitchen sinks, and drains. The green hospital should strive to minimize the use of toxic chemicals in food service preparation and service areas to ensure that natural and less harmful chemicals are used for cleaning and pest management. Education for all these new practices is essential for the staff. It is important that they understand the reason as well as the benefits of using local, organically grown food and natural housekeeping chemicals. Ongoing education on human and ecological health through nourishing food should be encouraged. This step will help in inculcating an understanding of human body and how it is affected by harsh chemicals and unsustainable food. Last but not the least, continuous evolution is critical for survival and growth in this era of erratic climatic changes. Therefore, key stakeholders of the hospitals must be identified and kept involved in the decision making process, redefining procedures, modifying protocols, and continuous improvement plans. When we talk about green rating systems for hospital in India, there are very few prevalent rating systems. Those are USGBC LEED, GRIHA, and IGBC. IGBC was developed on the framework of LEED few years ago. Now there are newer rating systems which are well edge have also been introduced to the country. The two major rating systems are compared here. LEED has specific variants of rating systems addressing the building typologies such as hospitals, hotels, commercials, etc. These variants include the specific concerns and limitations related to the sector within a broad foundation of resource efficiency, efficient operation, and maintenance. This approach makes the rating system dynamic and more in line with the building typology, since the experts from the sector were involved. In case of LEED for healthcare facilities, industry professionals help in identifying the specific concerns and integrating solutions to them. GRIHA, on the other hand, does not have rating system to building typology, but based on built up area and site area of the project. This means that there is no specific criteria related to the particular projects, but a holistic sustainability framework for all projects. This means the specific requirement and concerns of a hospital are not addressed in rating system. The Green Guide is healthcare sector's first quantifiable sustainable design toolkit, integrating enhanced environmental and health principles into the planning principle design, construction, operation and maintenance of their facilities. It provides the healthcare sector with a voluntary self-certifying metric toolkit of best practices that project teams can use to guide and evaluate the progress towards high performance healing environments. Issues such as 24 days, 7 hours operation, energy and water use intensity, chemical use, infection control requirements, and formidable regulatory requirements can pose significant obstacles to the implementation of currently acceptable sustainability protocols. The guide has been developed on the framework of LEED rating and focuses on health issues specifically. Few examples of LEED and GRIHA rated green hospitals in India can be seen here. as it is clearly visible, there are very few hospitals being certified as a green hospitals, probably due to the lack of specific and detailed criteria present in the rating systems. Hope you all have understood, and in case if you have any doubts regarding this module, we shall discuss it on the discussion forum. Thank you. Namaskar.